What's up? My name is Evgeny and in this video we'll talk about slices. Check video about arrays. If you don't see it, you need to, because here we will often use arrays. What is a slice? A slice is a sequential collection of elements of the same data type. Like an array, but no fixed length. Why do we need slices? Slices are useful when we need a collection of elements and we don't care about its length. Let's say we need a function that accepts a collection of numbers and returns only even numbers. To do this, we need to use slices. And we can see result in the console. How to declare a slice. To do this, write var slice name brackets type. This creates an empty slice with 0 elements. Let's create a slice of numbers. To do this, we need to write var numbers brackets int. And we can see in the console that the slice is empty. How to shortly declare a slice. To do this, write slice name equals brackets type volia1, volia2 and so on to volia n. This creates a slice with n elements. Let's say we need a slice with 5 names. We need to write names equals bracket strings Susan, John, Victor, Marta, Michael. And we see these 5 names in the console. How to add an element to a slice. To do this, write slice name equals append slice name volia1, volia2 and so on to volia n. This will add n elements to the slice. Let's say we have a slice with 2 numbers, 1 and 2, and we want to add numbers 3, 4 and 5. To do this, we need to write numbers equals append numbers 3, 4 and 5. And we see in the console 1, 2, 3, 4, 5. What is slicing? Let's say we have slice A and we want to get part of A and set it to B. To do this, we need to write B equals A low high. This operation creates a slice B that contains elements from A, with indices ranging from low inclusive to high exclusive. Also, you can choose not to write low. This will be 0, or you can choose not to write high. This will be the length of the slice, in our case is a minus 1. Also, you can do this with arrays. As an example, let's say we have a slice with 5 numbers, 1, 2, 3, 4, 5. And we need a new slice with only 2, 3 and 4. To do this, we need to write numbers 2 equals numbers 1, 4. We need to write 4, not 3, because the second index is exclusive. And we only have a slice with 2, 3 and 4. We can see this in the console. But here we have a very big pitfall. Let's go back to our example with numbers. Now we have a slice numbers 2 with numbers 2, 3 and 4. Now we want to add 13 to it. To do this, we need to write numbers 2 equals append numbers 2, 13. Okay, all is well. But let's look at the slice numbers. And here we see 1, 2, 3, 4 and 13. Boom, we changed the first slice by changing the second one. Why is that? How do slices work under the hood? Slice has 3 elements under the hood. The first is a pointer to the underlying array, the second is the length, and the third is the capacity. What is a pointer to the underlying array? Slices do not contain data, so they have pointer to an underlying array containing the data. Why do we need a capacity? The capacity is the capacity of the underlying array. We can also say that this is the length of the underlying array, because in arrays length equals capacity. Let's say we have a slice with 3 numbers, 1, 2 and 3. I will use len to get the length and cap to get the capacity. So we see in the console that its length and capacity are 3. But if we add 4 to the slice, we can see that the length is 4 and the capacity is 6. So the capacity is not 4. But in the console we see only 4 numbers. Also, if I write number 6, I will have a slice with 6 numbers. 1, 2, 3, 4, 0, 0. But if I write number 7, I will get an error. So why do we need capacity? We need capacity to optimize adding speed. Imagine that we don't have slices and we want to add an element to an array. To do this, we need to create a new array with length +1. Copy the elements from the first array to the second and set the last element. So it's a very expensive operation, and for optimization we create an array not with length +1, but with length multiplied by 2. This way we can add length elements without having to create a new array. But what is the logic in this? Why multiply by 2 and not by 3 or so on? There is a good chance that if you have a slice of n elements, you will want to add n more elements. For example, there is a high probability that you will add 2 more items if you already have 2 items, and an equally high probability of adding 1 million items if you already have 1 million items. This is the reason why we need capacity. What is length? The length is the limit for the slice. We cannot get an element with an index greater than length -1, or set an element with an index greater than length -1. For example, if we create a slice with 4 names and a capacity of 10, we do not want to iterate over all 10 names, 6 of which empty lines. Now we can return to our pitfall example. When we create a new slice numbers 2 from numbers, we don't create a new underline array. We create a new array only if the capacity runs out, but that's not the case here. So in this example, the first and second slices have pointers to the same array, and this is a trap. What do we need to do? We can write b equals a low, high, max. So here we are setting the initial capacity for our new slice. Capacity is equal to the max minus low. So for our example, we need to write numbers 1, 4, 4. And now when we write append, the capacity is 3, and we need a new underline array. Now we have no pitfall, but this does not prevent change pitfall. We will talk about it later. One simple rule: low less than or equals high, less than or equals max. This is just the logic. How to make a slice? Let's say we need a slice of numbers with an initial length of 5 and a capacity of 10. To do this, we write numbers equals make int 5, 10. This creates a slice with an initial length of 5 and a capacity of 10. We can see this in the console, how to get an element from a slice. To do this, write slice name n. N is an index here. N cannot be greater than the length of the slice minus 1. Length, not capacity. Let's say we have a slice with 3 numbers 10, 20 and 30, and we need the element at index 2. We write numbers 2 and this is 30. We can see this in the console. How to change an element in a slice? To do this, write slice name n equals v. N is an index and v is a value here. N cannot be greater than the length of the slice minus 1, since it is the last index in the slice, and the type of v must be the same type as the type of slice. Let's say we have a slice with 2 names, Jordan and Michael, and we need to change the element at index 0 to Victor. To do this, we need to write name 0 equals Victor, and we now have Victor and Michael. We can see this in the console. Another pitfall with slices. So back to our example with numbers. Now we don't want to add an element, but we want to change it. Let's say we want to change 2 to 6. To do this, we need to write numbers 2, 0 equals 6. And now we have 6, 3 and 4. But let's look at the numbers. And here we have 1, 6, 3, 4, 5. The same pitfall. So how to fix it? We can do it with the built-in method, but we can write a custom function. So here we are creating a temporary slice with the type of the original slice and the length and capacity of the original slice. We then make a deep copy of the original into a temporary slice. We then slice in on the temporary slice and set TMP to nil, and we return a result. And it's all. Deep slicing. Result in the console. That's all I wanted to say about slices, but also I have 3 formulas for you. Check the description. In the next video we will talk about maps. Subscribe so you don't miss it, and see you in the next video.